Simplifying factorials, recall that n factorial is defined as n times n minus 1 times n minus 2 times and so on times 3 times 2 times 1. So if that be the case, they want us to simplify these factorials. So n plus 1 factorial is defined as n plus 1 times n factorial. This is divided by n factorial. So the n factorials cancel out, and all you have left here is n plus 1. This can be simplified as n factorial over n plus 2 times n plus 1 times n factorial. So the n factorials here cancel. We have left 1 over n plus 2 times n plus 1. What about this one? The 2n plus 2 is bigger than the 2n, for the factorials. So this is 2n plus 2 times the next term minus 1, size, n minus 1 size less than that. So this is 2 times n minus 1 plus 2 factorial. And this is all over 2n factorial. So this is 2n plus 2, and this is 2n minus 2 plus 2, right? 2n minus 2 plus 2 factorial all over the 2n factorial. So this is 2n plus 2 times 2n factorial all over 2n factorial. The 2n factorials cancel out. So we have left here 2n plus 2. Now, let's find the limit of the sequence to determine whether or not the sequence converges or diverges. If it converges, here it says find the limit. The limit as n goes to infinity of 5 over n plus 2. Just think about, n as being as x goes to infinity. Here, 5 over n plus 2 as n goes to infinity. This goes to 0. So this is the limit. If you have a limit, a fixed number, then we say that the sequence converges. Okay. Now, there was something in this section we talked about the bonded sequence. If it's bonded and if it's monotonic, then it converges. And if one of those two criteria fails, like if it fails to be bounded, if it fails to be monotonic, then the sequence is not convergent. Well, let's see. Notice here that the limit without the negative 1 to the n, the limit would oscillate between, the limit would be 1. But since it's negative 1 to the n, the limit would be negative 1 or positive 1. So here, notice that the limit as n goes to infinity of n over n plus 1, this is equal to 1, right? The 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 degree, excuse me, of our numerator is 1. Our degree of our denominator is 1. So they have the same powers for the numerator and denominator. So the horizontal isotope is the ratio of the leading coefficients. That's just 1 divided by 1. We get 1. But the limit here is n goes infinity of this negative 1 to the n times n divided by n plus 1 is plus or minus 1, right? Because of this negative 1 there. This sequence is here, it is bounded. Yeah, we have an upper bound, which is positive 1. You have a lower bound, which is negative 1. But here, it's not monotonic. Since the sequence is not monotonic, it's oscillating, right? So it's neither going up, neither is it always going down. It's up and down, up and down. It's bouncing between negative 1 and 1. So here, since the sequence is not monotonic, by the theorem, the sequence diverges. Here, notice taking the limit, and I don't know if you recall that there was an old-fashioned method of taking the limit by dividing everything through by the so-called biggest term, or the big O, from computer programming. The biggest term is n squared. Dividing each term by n squared, you can produce the limit. But if you remember the test for the horizontal isotope, you can apply that as well. Look at the degree of the numerator is 2. Your degree of the denominator is 2. If they have the same degrees from the top and the bottom, then the horizontal isotope is the ratio of the leading coefficients. 10 divided by 2 is 5. And so you get the limit here is equal to 5 as n goes to infinity. So another way of doing that is we look at this sequence so we get the limit as n goes to infinity. Again, there's several ways you could do this. You can even apply L'Hopital's rule. Here, if we divide through by the biggest term, so we get 10n squared divided by n squared plus 3n divided by n squared plus 7 over n squared. This is over 2n squared divided by n squared minus 6 over n squared. the limit as n goes to infinity of 10. This is 3 over n, so this goes to 0. This limit goes to 0. This limit here goes to 10. And this limit here goes to 2. This limit goes to 0. So we get 10 plus 0 over 2 minus 0. So you get the limit of the ratio of constants is just the constant. You get 5. Applying L'Hopital's gives you the same thing. I think just using the horizontal isotope instead of going through all that mess, you get the limit. Now for this problem, we do, and I do encourage using L'Hopital's rule. We have the limit as n goes to infinity of the natural log of n to the third all over 2n. Now notice here that we have what we call an indeterminate form. You get infinity over infinity. So because of that, we apply L'Hopital's. The limit as n goes to infinity. Take the derivative of the numerator. And so this is 1 over n to the third times 3n squared. This is divided by 2. Take the derivative of the 2n, we get 2. So here we have the limit as n goes to infinity. 3n squared divided by n cubed is just 3 over n, and divided by 2. So this is 3 over 2n, and this is equal to 0, right, as n goes to infinity. So it converges. This was also convergent. What about this limit? So this is, we're going to break the factorial down, the numerator, because it's bigger. So this is n plus 1 times n factorial divided by n factorial. Now the n factorials cancel. So this gives us the limit as n goes to infinity of n plus 1. And as infinity goes to infinity, n plus 1 also goes to infinity. So we say here that this sequence diverges. Okay. Now, for this problem, I had to graph this. You can pick some number for p. P is said to be fixed. I graph this to see the limit. Now the graph of this does this, and this number here is any number p that you pick. I pick P to equal to 5. Since P is fixed, we'll pick that to be 5. And what happens is the graph, it increases up to that fixed point P. But after P, it diminishes. And so here it says P large. And so as n goes to infinity, this graph converges to the x axis, which is y equal to 0. And so we get the limit there to be 0. Now, in a nutshell, to see that the limit is 0, obviously e to the n is larger than n to the p. And so you get your denominator is larger than your numerator. The denominator increases in value faster than the values for the numerator. Thus, the limit comes out to give you 0. All right, converges for P being fixed. Well, I think I'll stop right there.